Can't go at 3. Gotta go at 9.
Is that no 3?
No 3. Got shot down.
Okay. Number 6.
Upside down.
What was the assignment, Mr. Aldrich?
1 through 14, 605.
Can I get my pictures?
Nope.
Since I didn't do
Even
it.
more reason for you to stay here and listen and learn.
What's the assignment?
Page 604, 1 through 14.
Hey, it's a bird. What?
It's a bird!
All right, number 9. Unfortunately, many of you got this wrong because you looked at it and you went, oh, well, if it cuts the angle in half, it cuts the side in half, so it's 5.
No.
But that's not correct. Okay? Just because it cuts the angle in half, no, you could twist and turn this opposite side all kinds of different ways to make it cut it into just about any sort of piece that you want. Okay?
Why is it so loud in here?
He's threatening me.
Okay, just not. Problems. So you have to set up a proportion. All right? So give me a number from up here.
X.
Okay,
12.
12. All right. So what number does the 12 go with?
15.
Okay, 2 different choices. She could have said the 12 goes with the X, or she could have said the 12 goes with the 15. She's going to go across like this. That's fine. So the 12 goes with the 15. So since she started on the right side with the 12,
Yeah.
we have to stay on the right side and go with the X. The question is, what is the length of this piece right here? Because that's the number that the X goes with. All right? And since this whole thing is 10, and this much is X, then that means that this missing piece right here is 10 minus whatever X is. Okay? So that's what goes on the bottom of this proportion, 10 minus X. Now, since we have 2 X's in here, that makes it a little bit trickier to solve it, but the idea is still the same. I'm going to cross multiply. So if I go 12 times this stuff, what do I get?
120 minus X.
120 minus 12x, because I have to multiply both terms by 12. And if I cross multiply this way, what do I get? 15x. James, you got a question?
Yeah. Because those are even at the bottom.
How do you know they're even? Oh, these down here? Okay, right, gotcha.
So wouldn't that mean coming up?
No, and I'll show you why. I know that that's deceptive, but I could take this.
said that was no earlier.
Right, that's fine, I'll show you. So if I take this angle right here, and I cut it in half,
You want one?
okay? So let's say that this line right here goes, whoops, let's say that this line right here goes right down sort of the middle of the angle. Okay, close enough? All right, if I draw my third side like this, then they're going to be pretty close to cut in half, right? But if instead I decide to take this thing here and extend it so this one is way long, okay, this angle's still cut in half, right? And then I can take this side right here and make it really tiny. Is that angle still cut in half? Is that angle still cut in half? Yeah, it's still cut in half.
Well, it's still cut half, but it's not the same.
Right, but now if I complete my triangle with that side, hopefully you can see that this length right here is not the same as that length right there. Okay? So just because the angle is bisected does not mean the opposite side is. Okay?
We're still on 9.
Yeah, we're still on 9, but he was kind of had a question about why I can't just say that this is 5. Okay? So I was just trying to explain that. And now I got there. All right. Okay, so now I have this equation. How do I solve that equation?
You add 12x.
Yeah, I get my like terms together by adding 12x. So those cancel. 120 equals 27. My board's freaking out. 27x.
Divide by
27.
And then I divide both sides by
4.
27.
Repeating.
4.4, are you sure?
Yeah,
Repeating.
I said that.
Okay.
I got
4.4
you.
repeating, and you should all know Austin Crowley, Danny Roman. I don't know what's going on back there.
Daniel Sydney Berman.
I know, but you're not paying attention. Well, the problem is,
I can't pay attention.
there's maybe other people back there that you're talking to that don't.
I haven't said a word. Billy got that talk to him.
Well, that's a definite good example of a kid who does not have this. You don't even have your book, you don't even have your paper out or anything. Guaranteed you don't have this. All right, so that's number 9. Let's take a look at number 11.
10 was easy.
Hey, wait.
10 was easy.
Because there's, they're easy enough to do on your own, then you need to do them on your own. I only want to do the ones that have something tricky in there that you might need help with.
I didn't.
I will,
7.
yes.
I need help with 7.
Okay, number 11 is a funny one because we actually don't even use similar triangles. Okay? And the reason why we're not going to use similar triangles in this problem is because if you look at this, they've only given us 2 numbers to work with. And if we're going to use similar triangles, we need 3 so that we can cross multiply and divide. Okay? Does anybody see another number that we can use instead? The 30. What does that tell you? What kind of triangle is this big old
30,
triangle?
60, 90.
30, 60, 90. So if this is a 60-degree angle, what are each one of these? 30. All right? And then the fun part about that is that now we get to know something about this big triangle on the left and this triangle right here. They're not both 30, 60, 90. Well, right, the whole thing is a 30, 60, 90. And now this one right here is also a 30, 60, 90. What kind of triangle is this one right here?
30, 30 something.
And the main thing is you said 30 twice, so it is a isosceles triangle. So that means whatever this side is right here, this side will be the same thing. Correct?
Well, then,
Okay? Well, since this is a 30, 60, 90 triangle, we know what this side is right off the bat. It's twice the short leg. Okay? Because in a 30, 60, 90 triangle, the hypotenuse is always double the short leg. So if this is 3 root 3, then this has to be twice that, or 6 root 3. And if this is 6 root 3, since this is an isosceles triangle, that means that k is 6 root 3 also. All right?
I just made a sick person on my phone.
Oh, well, it's a happy day.
how do you do that?
That makes up for it raining about 10 inches today.
Huh?
No, she stole mine. Okay, we good with that one?
Wait.
Somebody stole it from you.
6 root 3.
Maybe the Jen cousin.
What?
Hi, Jen.
She
She be okay. She need a nappy now. She tie-tie.
Huh?
She tie-tie. Somebody needs to show me how to get to Apu's house. I don't know which road to take.
Yo. Nope.
What was 11?
Is it 3, 4?
Noah. What was 11? What was 11?
6 or
All right, let's take a look at number 12.
You know, such a kind soul.
Okay, kind of the same game as the last 2 problems that we did combined.
Oh,
First of all,
that's sweet.
they tell us that these 2 lines are parallel. That must be important for some reason. If I know that these 2 lines are parallel, what does that say about this angle right here and this angle right here? They're the same because they are alternate interiors, okay? So once again, just like in the last problem, I have created a what kind of triangle? Isosceles triangle. So if this side here is x, then this side right here must be x as well. All right? And so now we can set up a proportion, x over 10. So I went little triangle, big triangle equals what over what? You're thinking this side right here, but what is that side? other way around, 15 minus x. So that's going to be, it equals 15 minus x over the whole side, which is 15. Okay? And then now, just like number 9 that we started with, we've got 2 x's in the problem, but we're okay. We can still cross multiply and solve that. What do you get when you cross multiply?
15x.
Okay, if I go this way, I get 15x. And if I go this way, I get what, Jake? 150 minus 10x. All right. And then we just solve it the same way we did the other one, which is add the 10x to both sides. So that's 25x equals 150. And then I divide both sides by 25.
It's 6.
So x equals 6. Okay, so once again, James, unfortunately, you wanted to say this was half of that because this angle's half of that. Yeah, that's not how it goes. So, okay, I will do 13, but it's ugly. Okay?
Okay, can we just skip
Am I
it?
No, we can't skip it, but I'm just warning you, there's going to be some bloodshed, so be ready.
Let's do this.
13.
Okay, you ready?
Yeah.
And I'm the closest.
Okay, 13. So we have this triangle right here, which conveniently is what kind of a triangle? This is a
Right.
right
30, 60,
triangle.
90.
Okay. Oh, now wait a minute.
It's just a guesstimation.
Do we want to use the guesstimation?
No, but I was just a guesstimation. You told me to guess a lot this morning.
No.
Uh-huh.
Oh, I told you to guess to get yourself started, and then I
I'll
told you
sign your
whether it
name
was right.
on it, so it has to be theirs.
What?
Okay, so for number 13, we do have a triangle. It does have a 90-degree angle, but it is not a 30, 60, 90. They did not tell us that this is 30. They did not tell us that this is 60, so we can't assume that it is. Okay? So we're just going to set up a proportion. So give me a proportion I can use.
And 5 x to z.
5
5 over 5.
over, I'm not going to use y.
13.
5 over 13.
X over z.
Okay, good. So 5 over 13. So this side over that side
Hey.
equals this side over that side, okay? Now, this is where the ugly part of this problem comes in. I have 2 letters in that equation, okay? So we're just going to have to work with that. Cross multiply, tell me what you get.
5z, 13.
5z equals 13x. So what I'm going to do is I'm going to take and I'm going to solve that either for x or for z, I don't care which one. Solve it for
Both.
z is a little bit easier,
Z for scout.
okay? So if I divide both sides by 5, what is 13 divided by 5?
5.
2.6x, okay? So we know that z is equal to 2.6x, all right? So what I'm going to do then is I'm going to take this and replace it with 2.6x. So if I replace that with 2.6x, now I can look at this whole entire side, and how long is that whole side? 2.6x plus x,
5.2.
which is how many x's altogether? 3.6 x's. Okay? Yeah, 2.6 x's plus 1x is 3.6 x's. I don't know, I might not have drawn it to a scale.
5?
Okay?
Wait, I
Okay,
think that's-
so now I'm going to use the fact that this is one big right triangle, so that tells me I can do the what? The Pythagorean theorem. Good.
Oh, you brought
So
me.
5 squared plus, so this leg squared plus this leg squared, so plus 3.6x squared equals the hypotenuse squared. Now I need a little bit of calculator help. What's 3.6 squared?
I don't know.
What is it?
I know.
12.96?
Yeah, sure.
Okay, so that works out to be 12.96 squared equals 169. So it's what?
No, the X.
Just the x is squared, yeah. So I'm going to subtract 25 from both sides. So the 25's cancel, so 12.96x squared 144. How do I solve that? Not yet. I first have to divide by 12.96. I could have taken the square root. Oh well. So I divide by 12.96, so 11 squared equals 11.1 repeating. And then how do I figure out what x is? Square root it. And so x equals 3.3 repeating. Okay? So that's a little tricky, very tricky in fact. So we had to use a proportion to figure out what one of the variables was in terms of the other, and then use the Pythagorean theorem to figure that one out. But now that I know what x is, I'm money.
Money.
What can I do with the x to figure out what z is?
Plug it in.
Multiply it by 2.6.
Just kidding.
So 3.3 repeating times 2.6 is?
8.58.
8.58? Okay, so now that tells me that this whole side, well, let's see. Oh, now I know that this right here, I figured out that x was 3.3 repeating. Right, so now we have to figure out what y is. So now let's dial into this little triangle right here. What can I do to figure out what y is? Pythagorean theorem again. So this time 5 squared, plus 3.3 repeating squared, is going to equal y squared. So I'll do the easy one. 5 squared is 25. 3.3, what is it? We haven't learned how to do a proportion with this middle thing here, have we? What, Danny? 11, oh yeah, because it came from the square root of that. Nice job. 11.1 repeating equals y squared. So that means that y squared is going to equal 36.1 repeating, and if you take the square root of that, you get y equals 6 point something. I'm just going to round it to 6.
Square root of what?
Square root of 36.1 repeating.
That one's brutal.
Yeah, I told you that was a little bit icky. No, this one it looks crazy, but it's not.
That's it.
Can I be involved?
Nope.
This is the class I need most.
Do you need any mustarding in it?
Wait, you're 14.
I'm so tired. Austin can? Oh, never mind. I have counseling after school.
Not bad at all, actually. Okay, so this one we just need to find a couple of missing pieces here. And I know it looks crazy, but like I said, it's not, because since these things, they have those dotted lines on there. Oh, I guess I didn't make it match up, so I won't do that.
It looked good now.
How many times bigger is this x coordinate than that x coordinate?
It's like almost twice as big.
7 divided, almost twice as big. 7 divided by 4 is what?
Never mind.
Close.
1.75.
1.75. How many times bigger is this y coordinate than that y coordinate?
It's 1.3.
1 3/4, which is 1.75.
Oh,
So that means that all of the coordinates of this shape are 1.75 times bigger than the coordinates of this shape. Or you could go the other way around and say all the coordinates of this shape are 1.75 times smaller than the coordinates of this shape. So if I want to get this coordinate right there, what do I do to the 1? 1 and 3/4, right. I just take and multiply it by 1.75, which comes out to be 1 and 3/4. How do I figure out the y coordinate?
3, 4. 1 and 3, 4.
I multiply 4 by 1 and 3/4, which comes out to be 7.
7.
Okay? Now if I want to go backwards and I want to figure out this x coordinate, what do I do with that x coordinate to find it? I divide by 1.75. And if I do that, I get 3. Good. And then what do I do to this to get this one? I divide by 1.75, and when I do that, I get 5. Okay?
Nice.
So that's the coordinates of the points, and again, that just comes from the fact that this shape is 1.75 times bigger than this one. Okay? So what is it, h to k or k to h? K over h. So k over h is 1.75. All of those are 1.75 times bigger than the other.
We use 7.
Wait, I got a point.